Hello, sir. This is myself, Shomik Debnila, and my team members are Mohammad Asasjuman Shorkar Onik, Mohammad Jadul Hokta Shrik, Abdullah Jamal Sifat, and Mashur Rafi. Now, I'm going to start my presentation, and it's federated learning for empowering large language models. Firstly, I want to start with the background and related work. Firstly, the remarkable progress in natural language processing achieved through large language models has pro- propelled the field into new dimensions. Models like GPT-3 have demonstrated unprecedented abilities to understand, generate, and manipulate text, enabling advancements in a wide range of applications. However, these models come with significant computational requirements and demand substantial amounts of training data to reach their full potential. Now, related work. In response to the privacy and efficiency challenges faced by centralized training, federated learning has emerged a promising paradigm. Federated learning enables collaborative training across decentralized devices while keeping data localized. The idea of federated learning was initially proposed by McMahon. Federated learning has extensively studied and applied in the context of various machine learning tasks, but its application to large language models is relatively nascent. A few studies have explored FL for NLP tasks, recognizing its potential to overcome the limitations of centralized training. Next, federated learning for large language models. Firstly, it comes with compatibility with large language models. Large language models such as GPT-based architectures process massive parameter spaces and exhibit sequential dependencies. Then, addressing privacy concerns. One of the primary advantages of FL for large language models is its inherent privacy preserving nature. Then, adaptive aggregation strategies. In the context of language models, aggregation strategies play a vital role in refining the global model. Standard methods like averaging can be extended to sequential data by considering the next of the language, conversion speed, and performance. Language models often require extensive training iterations for convergence. Federated learning introduces the potential for parallelism as devices can perform updates concurrently. Then, strategies for federated language model learning. Firstly, aggregation method. Aggregating model updates from diverse devices is a pivotal step in refining the global language model. Several aggregation methods can be employed to synthesize updates effectively. These methods encompass simple averaging, weighted averaging, and advanced techniques such as federated averaging. Then, communication protocols. Efficient communication protocols are crucial to minimize data transfer and latency during the federated learning process. Devices can be communicate with the central server through various methods, including parameters compression, quantization, and secure aggregation. Then, optimization technique. Optimizing the training process in federated language models is essential to enhance the convergence speed and overall performance. Techniques such as federated scholastic gradient descent and federated averaging with momentum can be adapted to the language model context, contributing to improved model updates and convergence. A comparative analysis. Centralized training involves aggregating all data at a central server, leading to faster convergence due to availability of a comprehensive dataset. However, federated learning deals with decentralized, potentially non data across device, affecting convergence speed. The adaptability of federated averaging and optimization techniques can mitigate this disparity. Centralized training requires data to be sent to central server, raising concerns about data privacy and security breaches. Federated learning inherently preserves data privacy by keeping raw data localized on device, sharing only model updates during aggregation. Communication overhead. Centralized training involves substantial data transfer between devices and the server, leading to communication overhead. Federated learning reduces communication overhead as only updates are exchanged, which can be compressed and transmitted more efficiently. Results: the experimental evaluation of centralized training and decentralized training was conducted to compare their performance in terms of accuracy. The performance gain observed in the decentralized training approach um, reaffirms the advantages of collaborative training and data diversity. The initial results suggested federated learning offers a promising avenue for advancing large language models while ensuring data privacy and decentralized collaboration. Here I have inserted a graph. Future work and real world applications. Uh, the future works can be included by improving privacy preserving techniques, federated transfer learning, efficient communication and rescue optimization, adaptive federated learning, robustness and security, federated learning, multimodal language models, and real world applications and case studies. Finally, federated learning has emerged a promising approach for training large language models while addressing the challenges of data privacy, communication efficiency, and data decentralization. The paper explored the concepts, principles, and strategies behind federated model training and its applications in natural language processing. Through a comparative analysis, we highlighted the advantages and trade-offs between centralized training and federated learning. While centralized training offers faster convergence, federated learning preserves data privacy and reduces communication overhead. The choice between these paradigms depends on the specific context and requirements. The application of federated learning in NLP offer diverse opportunities for collaborative model training across devices without compromising user data. Sentiment analysis, language um, translation, and named entity recognition. Next, summarization and question answering are just few examples of NLP tasks that benefit the federated learning framework. That's all about my paper. Many thanks to my group mates and our honorable supervisor.